Okay, so in this lesson, we're going to learn how to solve rational equations. Now, a rational equation, by definition, is an equation containing one or more rational expressions. Okay, so remember rational expression, when you simplified rational expressions, or when you multiplied rational expressions, or when you added and divided. Remember this whole, you had many lessons that dealt with rational expressions. So for example, a rational expression looked like this: x plus 5 divided by x plus 2. All right, and so an equation, a rational equation would be an equation that has one or more of these. So kind of like 1/2 equal 2. That would be a rational equation. Okay, so that's an example of a rational equation. Another example would be something like x plus 6 divided by 4 minus 2 over x plus 1 equal 1 over 3. That would be another example of a rational equation. So notice that these two rational equations, if you look at the denominators, they contain variable expressions. So this is a variable expression, this is a numerical expression, but sometimes it does contain variable expressions. So we're going to start out with solving a very simple one. So we're going to solve a very simple rational equation. So for example, number 1, let's suppose we had x plus 1 divided by 4 minus let's say 2x minus 3 divided by 2 equal 1/3. Okay? Suppose I had this rational equation. Now, this rational equation, because it's made up of rational expressions. In fact, if you look at this, there are 3 rational expressions altogether. Now, the whole point, the first thing you want to do when solving a rational equation is you want these denominators to be 1s. See, these denominators are 4, 2, and 3. You want them to be 1. You want those factors to be 1s instead. So what you're going to do, since this is an equation, remember what you do to one side, you do to the other. Since this is an equation, you're going to have to find the LCD. Okay, you're going to have to find the LCD. So the least common denominators. So look at all those 3 rational expressions and look at the denominators, 4, 2, and 3. What's the smallest number that 4, 2, and 3 will go into? The least common denominator, the least one. Always use the least. It doesn't matter what common denominator you use, it's common denominator, but use the least. It makes things a lot easier for you. So the least in this case looks like it will be 12. So least common denominator is 12 in this case. And so once you find the least common denominator, so that's step 1. So step 1 is to find the least common denominator. So then step 2, what you're going to do now is to clear your fractions. You're going to multiply both sides by the LCD. So you're going to multiply both sides by the LCD. All right, now listen carefully to this part. Look, if you look at the left side, there are 2 rational expressions. On the right side, there's only 1 rational expression. So since there's more than 1 on this side, I'm going to put this whole part in parentheses, just like this. Okay? And then on this side, since there's just 1 rational expression, I'm going to leave it as 1/3. And then I'm going to say I'm going to multiply this by 12, multiply this by 12. So the whole point of multiplying by the LCD is to clear the fractions. I'm using the word clear the fractions. That's the whole point of multiplying by the LCD. All right, now once you multiply both sides by LCD, the next step is to get rid of these brackets. So I'm going to distribute. Okay, so I'm going to get 12 times x plus 1 divided by 4 minus 12 times 2x minus 3 divided by 2, that's what this is, equal, I'm going to leave this as 1/3 times 12 for right now. Now here's an important thing you got to remember. You see this numerator? that has more than one term in it. That has two terms. So put that in parentheses. Same thing here. Put that in parentheses. If you don't put it in parentheses, chances are you will make an error at some point in this process. Since this is just one term, I'm going to leave it as one term. I don't need parentheses. And you're going to see why as we go through this. So I'm going to go ahead and rewrite this over. Minus 12 times 2x minus 3 divided by 2 equal 1/3 times 12. All right, now I'm going to the next step, so multiply both sides by LCD. So what we did at that point, step 3 was remove grouping symbols. Remove grouping symbols. Okay, so remove grouping symbols at this point. And then when we do that, we're also going to put, I'm going to put step 3A and step 3B, reduce. So we're going to reduce and remove grouping symbols. So I'm going to reduce first. So 4 into 4 is 1, 4 into 12 is 3. Now, the whole point of putting that in parentheses was because x and 1 has to be multiplied by 3. And then over here, 2 into 2 is 1, 2 into 12 is 6. So I'm going to multiply this. Think of this as negative 6 now. You're going to multiply both of these by negative 6. And then 3 into 3 is 1. 3 into 12 is 4. And then 4 times 1. Okay? All right. So then I get 3x plus 3. And then negative 6 times 2x is negative 12x. And negative 6 times our negative 3 is a positive 18. Equal, and then 1, this is 1 right here. 1 over 1 is 1. 1 times 4 is 4. All right, and then the next step, step 4, is to solve the equation. So we're going to end up, in all of these, we're going to end up with linear equations. So notice I went from an equation that had fractions to just a regular linear equation. So solve the equation. Okay, so solve the resulting equation. All right, combining like terms, I get negative, let's see, that's 9x plus, and then that looks like 21 equal 4. Subtracting 21 from both sides, I get negative 9x equal, that looks like 17. And then divide both sides by negative 9. I found the solution. So my solution is x equal negative 17/9. Okay? All right. So the first thing you need to do is to find the LCD. So let's kind of review this real quick before we go to another one. So you have this rational equation. You need to clear your fractions. So you're going to clear the fractions by finding the LCD. So the LCD is 12. So then you're going to multiply both sides by 12 to clear your fractions. So notice that since this side had more than one rational expression, I put that in brackets or parentheses, and then I distribute. Since this numerator had more than one term, I put the numerator in parentheses because that's important, because when you reduce, you have to distribute that number in every term in that parentheses. Same thing here. You have to distribute that number with everything inside the parentheses. So you reduce every part. So there were 3 rational expressions. So notice I reduced 3 rational expressions. And then you end up with a linear equation. For us, for this lesson, all these are going to be linear equations. You end up with a linear equation. You solve the linear equation, you found your solution. So the solution is negative 17/9. Okay, number 2. We're going to do another one with the denominators being numbers. And then we'll look at the denominators that involve something like variable expressions. Okay, number 2, let's suppose we had this. All right, let's suppose you had negative 4 divided by 7 minus, let's just say plus x plus 5 divided by 2 equal 2x plus 1 divided by, let's say 2. Okay, so I have these rational expressions, and so I have this rational equation made up of 3 rational expressions, and so I need to clear those fractions. And so I got to find the LCD, the least common denominator of all these three denominators. So 7, 2, and 2, your LCD is going to be 14. So step 1 is to find your LCD. Once you find your LCD, remember the next step is to multiply both sides by 14, which basically you're going to take each of those rational expressions and multiply by 14. All right, so basically you're saying if you think about it, you're saying negative 4 sevenths plus x plus 5 divided by 2 equal 2x plus 1 divided by 2. You're going to say times 14 times 14. And in particular, and you can skip this step right here because what's happening is that all of these fractions, all of these rational expressions, you're going to say times 14 times 14 times 14. But the reason you do that is because you're multiplying both sides by 14. That was one of the steps. And so you're going to say 14 times a negative 4 divided by 7 plus 14 times x plus 5 divided by 2 equals 2x plus 1 divided by 2 times 14. Now remember, at this point, before you reduce, you're going to ask yourself, do I need parentheses anywhere? So here, since that's just one number, one term, I don't need parentheses. Here, since that's more than one term right here, that's two terms, I need parentheses because remember, when you reduce, 2 into 2 is 1, 2 into 14 is 7. If you don't put in parentheses, you're going to make the mistake and say that's 7x plus 5, and it's not. It's not 7x plus 5. It's actually 7x plus 35. Okay? Same thing here. Put that in parentheses since that's more than one term. Okay, now we'll go ahead and rewrite this over. And then I'm going to reduce. So the next step is to reduce. Okay, reduce. So the next step is to remove the grouping symbols. Reduce. So reduce, remove the grouping symbols. Okay, now let's go ahead and reduce. 7 to 7 is 1. Remember, that's the whole point of clearing the fractions. You want to clear the fractions. You want these factors to be 1s. 7 to 7 is 1. 7 to 14 is 2. 2 times negative 4 is a negative 8. Plus 2 to 2 is 1. 2 to 14 is 7. You're going to distribute a positive 7 plus 7. Distribute plus 7. So I get 7x plus 35 equal 2 to 2 is 1. 2 to 14 is 7, and then distribute the 7. So I get 2x times 7 is 14x. 1 times 7 is 7. So that's what I end up with. Okay. So notice now this is so I went from a rational equation to a linear equation. All right, so let's solve this linear equation. So I'm going to combine like terms. So I get 7x plus 23, and negative 8 plus 35 is 23, equal 14x plus 7. All right, let's bring the variables to the right-hand side. So I'm going to subtract 7x from both sides. So I get 23 equal 7x plus 7. Then I'm subtract 7 from both sides. And so I get, on this side, when I combine like terms, I get 7x. Over here, 23 minus 7 is going to be, looks like 16. And then divide both sides by 7. I get my solution to be 16 sevenths. Okay? All right, so that's number 2. All right, now number 3. So number 3, let's suppose we had this. Number 3. Let's suppose we had 3 divided by x minus 2 plus 4 divided by x plus 5 equal negative 2 divided by x squared plus 3x minus 10. All right, now notice I have this rational equation because it's made up of rational expressions, and there are 3 of them. First thing, remember, is you got to find the LCD. You want to clear these denominators. You want these denominators to be factors of 1s instead. So you got to clear your denominators. To clear your denominators, you got to find the LCD. All right, now, remember, to find the LCD, you got to factor first. So x minus 2, there's not much I can do with that. X minus 2, x plus 5 stays x plus 5. But if you look at that trinomial, now let me give you a little hint here. Chances are, when for this particular lesson for us at this point, chances are when you factor this, it's going to be one or more of these factors right here. So when you factor this, chances are it'll be these two, or it could be one of these. All right, so let's see, we're going to get x plus 5 times x minus 2. And then check it. X times x is x squared. The outer is a negative 2x. The inner is 5x. When you add them up, you get 3x. And then 5 times negative 2 is a negative 10. Okay? Now remember, when finding the LCD, your LCD has to include every factor you see. So I see an x minus 2. So that's part of my LCD. I see an x plus 5. So that's part of your LCD. And over here, x plus 5, x minus 2 is already there. Okay, so that's your LCD. That's the least common denominator. All right, so your least common denominator is going to include every factor you see. X minus 2, x minus 2, x plus 5, x plus 5. And remember, that's the least common denominator because remember, you want to make this a 1. Well, in order for that to be a 1 right here, when you reduce, in order for that to be 1, you better have an x minus 2 right here. Okay, so you need it. In order to make this a 1, you better have an x plus 5 right here. And so you need that. And over here, in order to make these 1s right here, then you better have it here. Okay? So that's your LCD. All right, now the next step is to multiply both sides by the LCD. So now remember, this has two rational expressions. I'll put that in parentheses. Now listen carefully as we go through this. Put that in parentheses or brackets, however you want to do that. Equal, and then that's negative 2. Now, don't leave it as this trinomial. Leave it as a factored form. Write it as a factored form. So x plus 5, x minus 2. And the reason for that is because now you're going to multiply by the LCD, which is this. So you're going to say times this. And you see, this is exactly this. So those will divide out. And then over here, same thing. X minus 2, x plus 5. Okay? So once you find the LCD, and remember, finding LCD, you are going to have to possibly factor, so keep that in mind, and then you're going to multiply both sides by the LCD. All right, now I'm going to distribute, just like we did before. So remember, when I get to that point right here, look at this. When I did this right here, I distributed. I multiplied every rational expression by 14. So notice all these rational expressions are going to be multiplied by the LCD. So you're going to say x minus 2 times x plus 5 times 3 divided by x minus 2 plus, and then this times the LCD times this, x minus 2 times x plus 5 times 4 divided by x plus 5 equal, and then I'm just going to go ahead, let's just go ahead at this point and let's go ahead and reduce these instead of writing it over. So x plus 5 into x plus 5, you get factors of 1s. And then x minus 2 to x minus 2, factors of 1s. And you're left with negative 2. Okay? Now, at this point right here, let's go ahead and reduce these. So, when I reduce those, I'm going to get x minus 2 will reduce into x minus 2. Remember, you get factors of 1s. And you're left, now be careful, you're left with, this is 1 times x plus 5 times 3. So you're left with 3 times x plus 5. Plus, same thing here. X plus 5's reduce, and you're left with x minus 2 times 1 times 4, which is 4 times x minus 2. And all that's equal to negative 2. Okay? So notice I went from a rational equation to a linear equation. A rational equation to a linear equation. All right? Now, let's distribute. So when I distribute, I get 3x plus 15 plus 4x minus 8 equal negative 2. And so I get, when I combine like terms, I get 7x plus, looks like 14, nope, I'm sorry, 5, 6, 7, 8, so 7x plus 7 equal negative 2. Subtracting 7 from both sides, I get 7x equal negative 9. And then divide both sides by 7, I get x to be negative 9/7. So that's your solution. Okay, now one thing I got to mention here is that if you notice that this rational equation contained contain variable expressions. Okay? So if I had gotten this right here to be x equal 2, all right, suppose, now remember, this is our solution, but suppose I had gotten this to be x equal 2. I did all this work, and I got x to be 2, okay? If you go back and you check that denominator, you see if you say x is 2, that is the solution, and it's not, but let's suppose it was, then 2 minus 2 is 0, and you cannot divide by 0. Same thing here. If your solution was let's say x equal -5, then you're dividing by 0 because -5 plus 5 is 0, and you cannot divide by 0. So the first thing you must do, and on the worksheet you'll say this: you got to find your restrictions. So the restrictions. All right. So what can't x be? So when I do all this work, I got to check to make sure that this is not one of your restrictions. Okay, so when you get to that point, is it a restriction? Well, your restriction is whatever makes the denominator 0. So x minus 2, I'm just going to do this here, restrictions. So where's x minus 2 equals 0? Well, x minus 2 equals 0 when x equals 2. So that's a restriction. So you'd say x cannot equal 2. Your other restriction, you do the same thing here. X plus 5 equals 0, so x equal -5. So that's your other restriction. So x cannot equal -5. So it cannot equal -5. So notice you use that not equal symbol. And these is already these. So you're done. So there are 2 restrictions. So number 3 had 2 restrictions because if you look at your LCD, you have 2 factors containing variables. So you set each of those factors equal to 0. So I did all this work and I got this right here. So is this a restriction? No, it's not. So that's your solution. So this is a solution. It is not one of those restrictions. Okay, let's look at another one. So number 4. So number 4, let's suppose we had this. Number 4. Let's suppose we had, let's say, 2x divided by x squared minus 5x plus 6 minus 3 divided by x minus 2 equal 4 divided by x minus 3. Okay? All right. So the first thing you need to do is before you got to find the LCD. But the first thing you got to do before you find LCD is factor this. So these already, you can't factor these, so that's x minus 2, x minus 3. And when you factor this, chances are, for us, it's going to be these right here. So let's factor this. So we get xx, 2, 3, minus, minus. All right, so see x minus 2, x minus 2, x minus 3, x minus 3. Now always check though, because it may not be one of these. So check, x times x is x squared, the outer is -3x, the inner is -2x, you get -5x, and then -2 times a -3 is a +6. All right, so let's find the LCD now. So your LCD has to include every factor you see. So I see a factor of x minus 2, I have to use it. I see a factor of x minus 3, I have to use it. I see a factor of x minus 2, I have to use it, I already have it. I see a factor of x minus 3, I have to use it, I already have it. So your LCD is going to contain 2 factors, x minus 2, x minus 3. Now remember, when finding the LCD, keep in mind that you want these denominators to be factors of 1. So if I want this to be a factor of 1, then I got to multiply by what you see. And this is what I see. If I want this to be a factor of 1, then I got to multiply by x minus 2. Well, there's an x minus 2. If I want this to be a factor 1 here, I got to multiply this fraction by x minus 3. And there's an x minus 3. All right, so there's your LCD. Now before we go on, let's find the restrictions. Once you find your LCD, your restrictions are easy. Just look at your factors. So basically you're going to say x minus 2 equals 0, and you solve for x. So x is 2. So your restriction is that x cannot equal 2. Now do the other one, x minus 3. X minus 3 equals 0, so x is 3. So the other restriction is that x cannot equal positive 3. So you have two restrictions, a positive 2 and a positive 3. Okay? All right, so now let's go ahead and multiply both sides by the LCD. So I'm going to go ahead and notice that on this side, you have two rational expressions, put that in parentheses. So you get 2x divided by, and then leave it in factored form, x minus 2, x minus 3, minus 3 divided by x minus 2. And we're going to multiply that by the LCD, x minus 2, x minus 3, equal 4 divided by x minus 3 times the LCD, x minus 2, x minus 3. Okay. Now the next step is to get rid of these brackets. So I'm going to distribute. So basically, remember, the whole point is to multiply every rational expression by the LCDs, and that's what we're going to get at this point. So I'm going to say the LCD times the first rational expression, x minus 2, x minus 3, minus the LCD, x minus 2, x minus 3, times the second rational expression, equal. And then at this point, let's just go ahead and reduce this. So notice right here, this x minus 3 reduces to this x minus 3. Get factors of 1. Make sure you put factors of 1s in those places. And so you have 4 times x minus 2. All you're left with here is x minus 2. And so that's what you see. See 4 times x minus 2. Make sure you rewrite out this. 4 times x minus 2. X minus 2 is in parentheses. Now let's go ahead and reduce these. So these x minus 2's here divide out. The x minus 3's divide out, and all you're left with is 1 times 2x, which is 2x. Over here, the x minus 2's divide out. Now be careful how you write this. So that's a negative 1 times x minus 3 times 3. The best thing to do is to rewrite this with the coefficient in front. So it'll be minus 3 times x minus 3. So remember, multiplication is commutative. The order in which you multiply does not matter. So a negative 1 times 3 is a negative 3 times x minus 3. All right? That's the best way to write this. Equal, and then 4 times x minus 2. Okay. So notice I went from a rational equation to an equation with no denominators that you visually see. Okay, and then the next step is to clear your parentheses. So we're going to distribute the negative 3, we're going to distribute the 4, and so I get 2x minus 3x plus 9 equal 4x minus 8. 4 times x is 4x, 4 times negative 2 is negative 8. Combining like terms, 2x minus 3x is negative x, plus 9 equal 4x minus 8. Adding x to both sides, I get 9 equal 5x minus 8. Adding 8 to both sides, I get 5x equal 17. And then dividing both sides by 5, I get x to be 17 fifths. All right, now before I box this, I should ask myself, is this a restriction? So, in other words, will this make my denominator 0? And the answer is no, because what makes your denominator zeros are 2 and 3. So remember, you're finding your restrictions. The restrictions are what makes the denominator 0. And so this is not going to make my denominator 0, because the only two numbers that make the denominator 0 is 2 and 3. Okay? All right, let's look at another one. So this will be number 5. So number 5, let's suppose we had this. Okay, so this is going to be number 5. Okay, number 5, let's say we had x divided by x minus 2 plus 1/5 equal 2 divided by x minus 5. All right, let's go ahead and make this right here. Let's say x minus 5. X minus 5. Let's make that x minus 5. So we have x divided by x minus 2 plus 1 divided by x minus 5. I'm trying to make remember we said that we're going to end up with a linear equation. I'm trying to make this linear. 1 divided by x minus 5 equals 2 divided by x minus 5. Okay, so that's not going. Let's just go ahead and change this. All right, let's change this. Let's make this number 5. So number 5. Let's suppose we had 1 over x minus 4 minus 5 divided by x plus 2 equals 6 divided by x squared minus 2x minus 8. Okay. All right. Now, first thing you're going to do is to find the least common denominator. Before we find the least common denominator, we got to factor the denominators. So chances are, remember, when you factor this trinomial, it's probably going to be one or more of these factors. All right, so always look for things like that. So that's x, 4, 2. This would be negative, and this would be positive. All right, and always check. X times x is x squared. The outer is 2x, the inner is negative 4x, and when I add them up, I get negative 2x, and then negative 4 times 2 is a negative 8. All right, so the LCD, remember the LCD has to include every factor you see, because remember, if I want to clear this fraction right here, if I want to make this a 1, a denominator of 1, then I got to multiply x minus 4. So I need an x minus 4 here. Same thing here. If I'm going to make this a 1, then I got to multiply this by x plus 2. So that's x plus 2. And then here, if I'm going to clear this, then I better see this, and I do. Okay? Okay, now, the next step is to multiply both sides by the LCD. So that's your LCD. Now, let's find the restrictions. So what's going to make my denominator 0? So x can equal what numbers? Well, what makes it 0? Well, this is 0, x minus 4 is 0 when x is 4. So that's one of your restrictions. X cannot be 4, because when x is 4, 4 minus 4 is 0. Your other restriction, you're going to say x plus 2 is 0. When is x plus 2 0? Well, x plus 2 is 0 when x is negative 2. So here's your other restriction. So you have two restrictions. And notice it goes with these factors here. So what makes it 0? Positive 4. What makes this 0? Negative 2. All right, now, so if we solve this and one of our solutions is this, then we're going to have a different discussion. Okay, so let's go ahead and multiply both sides by the LCD. So I'm going to put this in parentheses. So 1 divided by x minus 4 minus 5 divided by x plus 2. And that's being multiplied by the LCD, x minus 4, x plus 2, equal, and then 6 divided by, leave this in factored form, times, and then your LCD, x minus 4, x plus 2. Okay, now once you multiply both sides by the LCD, the next step is to distribute. So I have x minus 4 times x plus 2 times 1 divided by x minus 4. Now remember, let's go back and make sure you understand why we're doing this. So remember, I want this to be a 1 right here, so I better reduce. I have to be able to reduce. So x minus 4 and x minus 4. Okay? Minus, and then the LCD times the second rational expression. X minus 4, x plus 2, times 5 divided by x plus 2. Equal. And let's just go ahead, since I don't have much room here, let's just go ahead and reduce these. So x minus 4 is divide out, the x plus 2 is divide out, and you're left with 6. So equals 6. Okay, now let's go ahead and reduce these. So remember, the whole point of multiplying by the LCD is to clear those fractions. So notice I already cleared on this side. I no longer see a rational expression with denominators other than 1. So let's reduce this. So x minus 4 is divide out, and you're left with x plus 2 times 1 is just x plus 2. Okay, so that's 1. So x plus 2 times 1 is x plus 2. Now, I got to be careful over here, though, because when I when I reduce the x plus 2's, when I divide those out, remember, always make sure you put factors of 1s in their place. I get negative 5 times x minus 4. So I do need to make sure I write that as you see it. So negative 5 times x minus 4. equal 6. Okay, now I'm going to clear the parentheses. I'm going to distribute. So I get x plus 2 minus 5x plus 20 equals 6. Combining like terms, I get negative 4x, x plus negative 5x, negative 4x. 2 and 20 is 22 equals 6. Subtract 22 from both sides. I get negative 4x equal, let's see, what's that, 16? So 16. Negative 16. So negative 16, right? 16, 17, 18, 19, 20, yep. And then divide both sides by negative 4. I get x to be a positive 4. Okay, so that's why I got x to be. But remember now, 4 was a restriction. That was a restriction. And when I solved this linear equation, the only solution I got was 4. And 4 was a restriction, which means that 4 cannot be a solution to the original problem because 4 makes this denominator 0. And I can never divide by 0. Okay, now this is called right here. Now let me make a point. 4 is a solution to this linear equation. Okay, 4 is a solution to this linear equation, but it's not a solution to the original problem. And the original problem was not a linear equation. The original problem was a rational equation. And there was a restriction of 4 and negative 2. So 4 is a restriction. Now this is called, we call this an extraneous root, E-X-T-R-A-N-E-O-U-S, extraneous root or extraneous solution. Think of the idea of false. That's a false solution. False solution because even though you solved the equation, you got a solution, it is a solution to the linear equation. But it's not, it's a false solution. It's not a solution to the original because of the restriction. I could not divide by 0. I'm sorry. Yeah, I cannot divide by 0 because 4 made this 0. Okay, so then you would say as your answer you would say no solution. Okay, no solution. There's no number here. No number will make this equation a true statement. Okay? All right. So this is a situation where when we found the restrictions, our solution, when we solved this, we got a solution, and really we should call this a possible solution that didn't work because that solution we ended up with, x equals 4, was a restriction, which makes this an extraneous root, a false solution, because it is a solution. It's a solution to the linear, but it's not a solution to the original because this is linear, but this is not linear. This is rational. This is a rational equation with restrictions. Okay, let's look at this one. So this is number 6. Number 6, suppose you had 2 divided by x plus 1 minus 1 divided by x minus 1 equal 2x divided by x squared minus 1. Okay? All right, so before you find your LCD, the first thing you need to do is to factor. And so the only denominator I can factor here is this. So remember, that's the difference of 2 squares. So I'm going to factor this as x minus 1, x plus 1. Okay? Now let's find the LCD. So every factor you see has to be in the LCD. So I see an x plus 1, so I need an x plus 1. So remember, the whole point of having it in the LCD is that way when you multiply both sides by it, the x plus 1s will divide out. Your next one's x minus 1. I need it. That has to be in the LCD. So far, my LCD is a product of 2 factors. And I go to the next one. So here's my denominator, which I already have it in the LCD. So there's the LCD. So your LCD is composed of these 2 factors. Now let's go ahead and find the restrictions. I have restrictions here because I have variables in the denominator. So since I have variables in the denominator, see this x plus 1, what makes x plus 1 equal to 0? That's what you're asking yourself. Well, x plus 1 is equal to 0 when x equals negative 1. So x cannot equal negative 1. I have variables in the denominator here, so what makes this 0? Well, x minus 1 is equal to 0 when x equals 1. So the other restriction is that x cannot equal positive 1. And then here, I already have them listed. So x minus 1, I already have that. X plus 1, I already have that. Okay, so I have restrictions because I have variables in the denominator. Now, if you go back to the very first two problems that we did, the very first two problems, notice in that first problem, I didn't find the restrictions at all because there are no restrictions. Because ask yourself, are there any variables in the denominator? Will the denominator ever be 0? No, this denominator is always 4. This denominator is always 2. This denominator is always 3. So this example, I didn't worry about restrictions because there were not any restrictions. There weren't any. Same thing here. There aren't any restrictions here because those denominators are all numbers. There aren't any variables in the denominator. It's when I started with number 3 that I had to start worrying about restrictions, because in number 3, this is where you started having variables in the denominator. So then you have to ask yourself, what makes those denominators 0? And those are my restrictions. Okay? All right, so let's look at the next one. So this is number 6. All right, so number 6, so I found my LCD, I found my restrictions. Now the next step is to multiply all parts by your LCD. So multiply both sides by the LCD. So I'm going to put the left-hand side in parentheses, and then times the LCD, which is x plus 1 times x minus 1, equal 2x divided by, leave it in factored form, because if it makes it a lot easier if you leave it in factored form, because when you multiply by the LCD, you notice that these divide out right away. And you're just left with 2x on this side. Okay, now let's go ahead and distribute here. So I get x plus 1 times x minus 1 times 2 divided by x plus 1 minus, and then the LCD times this, x plus 1 times x minus 1 times 1 divided by x minus 1 equal, and then all you're left with here is 2x. Okay, now reducing this side, the x plus 1's divide out, and you get 2 times x minus 1. So you have 1 times x minus 1 times 2 is 2 times x minus 1, just like this. Okay, the x minus 1's divide out here, and you get minus 1 times x plus 1 equal 2x. Okay, distributing, I get 2x minus 2 minus x minus 1. A negative 1 times x is negative x. A negative 1 times a positive 1 is a negative 1 equal 2x. Combining like terms, I get 2x minus x is x. A negative 2 and a negative 1 is a positive, negative 3, rather, x minus 3 equal 2x. Subtracting x from both sides, I get negative 3 equals x, and I solve for x. I'm done. All right, so x is negative 3. Now I've got to ask myself, is this an extraneous root? Okay, so remember, that is a solution. This is a solution to this linear equation. But is it a solution to the rational equation? All right, all you got to do now is just check your restrictions. So is negative 3 listed here? And it's not, so that's a solution. So your solution is x equal negative 3. So a negative 3 is a solution. Now I'm going to take the time here and just check this one. Let's just check to make sure that it actually does work. So let's check it. Now you're not going to have time to check this on a test or a final exam, but we can check it here. So let's check x equal negative 3. Now I didn't do the others because it's a little bit more difficult to do the others because those were fractions. But since this right here is just an integer, I'm going to go ahead and check it. So go back to the original problem. Here was the original problem. I'm writing the original problem over. Okay, and where we see the variable x, you're going to substitute -3. So I get 2 divided by -3 plus 1 minus 1 divided by -3 minus 1 equal 2 times -3 divided by -3 squared minus 1. Okay, so I went back to the original problem. Where we saw the variable, I substituted -3. So then this becomes right here, that becomes 2 divided by a -3 plus 1 is a -2 minus 1 divided by -3 and a -1 is a -4 equal, so I want to see this side is equal to that side. 2 times a -3 is a -6. A -3 squared is 9. 9 minus 1 is 8. Okay, so that's what I get here. All right, now 2 divided by -2 is a -1. I am subtracting a -1/4. See this? I am subtracting a -1/4. Well, subtracting a -1/4 means adding a +1/4. And I want to see if that's going to equal, and let's just go ahead and reduce this. That's a -3/4 reduced. All right, now let's look at this. Let's focus on this sum right here. The LCD is 4. The LCD is 4. So I'm going to write two fractions with 4 as the denominator. And we're going to write this as -1/1. All right, so these denominators are already 4, so that means the numerator is going to stay 4. So 1/4 is equivalent to 1/4. -1 is equivalent to, in this case, it will be -4/4 because you're going to multiply both sides by 4. I'm sorry, both numerator and denominator by 4. And then when I add them up, a -4/4 plus 1/4 is a -3/4, which is what you wanted. Okay, so that means that -3 is a solution. Okay, so that was 6 problems. That should get you to understand how to solve rational equations. With in particular, where you have variables in the denominator. All right, and then also keep in mind that you have to find the restrictions first. So always find the restrictions first. And then if your solution is a restriction, then that solution is extraneous root. Okay? All right, so that's the end of this lesson.